and how it works and what are the types of switches we use in the keyboard. So today we learn about the LCD switchback circuit. So what is the LCD or is the switchback circuit? Firstly, what do you mean by switchback? Or in what cases we use this? How it was best, how the switchback was made. Next, I mean, what is meant by a switchback circuit? In what cases or for what purpose we use these switchback circuits? So switchback, it is made to disturb power to one part of the circuit when the other turns on. Some components used in it are MOSFET P channel, diode, capacitor, resistor, and load resistor. So MOSFET P channel is of FQP27P06 and next is diode and capacitor of 25 μF and resistor of 100 kilo ohms and half volt. So load resistor is of 6 ohms, 5 watts. Okay, this is what is meant by switchback circuit. So it is majorly made to disturb the power to one part of the circuit when the other turns on. Like for suppose the A part was turned on, so it disturbs the power on the A part. So for disturbing these to do this process, MOSFET P channel of QP27006 was used and a diode and a capacitor of 25 μF and resistor of 100 ohms and half volt and load resistor of 6 ohms and 50 watts. So these were the components which were present in the switchback circuit and these were used for the switchback process. So let's see the applications of the switchback. So the first application was 11572 prong LED bulb for use in vehicles. Like we use some of the vehicles where like most of the vehicles use the two prong LED bulbs for lights. So this was the main application of switchback circuit. So bulb uses 20 white and 1210 SMD LEDs and 34 yellow SMD LEDs. White LED is significantly brighter than the yellow. So yellow LED array in blue consumes a and white consumes 0.093 amps. So load resistor to trick the vehicle hardware. So here load resistor is used to trick the vehicle hardware, and the bulb uses 20 white and 12 1210 SMD LEDs and 34 LED yellow SMD LEDs. This was the configuration of the lights which we use in the vehicle. So the total LEDs used in the vehicle were 1157 two-prong LEDs. So let's look into the problem statement. So LED bulb purchased do not operate as planned. Add on to add on to the simple switchback circuit by adding a capacitor. Size components properly to keep the white light from turning back on yellow in flash. So figure out which side of the wiring instead load resistor. So how it was designed. So it was designed as multi-sum simulation to get a general idea of component size. Build actual circuit and adjust capacitor size until time delay is suitable. So this was the design, like this was the implementation how it was done. The switchback circuit was look into this. So this was the design of a MOSFET P. So this is how the MOSFET look like and the diagram of the MOSFET working. So how the implementation goes through. First, we need to install the circuit onto the vehicle to address any issues. So later, installation circuit using wires instead of building it on the breadboard. So these wires are like here you can see the wires which are directly attached into the vehicle. Okay, here we are not using any type of breadboard to attach the wires. Okay, so remove headlight and determine which side is from is running light and turn signal. So here in this step we need to remove the headlight and determine which side of the prong is running light and turn signal. So next remove wire covering to expose wires, splice in switchback harness into existing wires. So next future refinement is add heatsink to for load resistor, build nice sealed circuit board to hold capacitor, resistor and MOSFET. And this is all about the switchback switchback circuits. Yes, did you understand about the switchback circuits? Guys, does anybody have any kind of doubt regarding switchback circuits? So our next topic is about 8051 timer or counters. So let's start from the introduction. The microcontroller 8051 has two 16-bit timer or counter registers, namely timer 0 and timer 1. These are also known as T0 and T1. Okay. When used as a timer, the microcontroller is programmed to count the internal clock pulse. When used as a counter, the microcontroller is programmed to count the external pulse. Okay, the maximum count rate is 1 by 24 of the oscillator frequency. So the count rate is depending on the oscillator frequency. So when the timer is used, the internal clock pulse were programmed to count. When the counters were used by the microcontroller, then it is programmed to count the external pulses. So mainly the 8051 microcontroller has two timers that are T0 and T1. These are also known as timer 0 and timer 1. So the 8051 has two timers and counters. So timer 1, timer or counter 0, timer or counter 1. These are the two types of timers or counters present in the 8051. The registers used in the timer are timer 0 registers are TH0, TL0, and timer 1 registers are TH1, TL1. So again, it consists of TM mode and TCON. TM mode stands for timer mode register. TCON stands for timer control register. Okay. Next, the basic registers what are present in the microcontroller 8051. So registers THX and TLX are present in the 8051 microcontroller. These are 16-bit wide. So these registers stores the time delay as a timer, the number of events as a counter. Timer 0 has a TH0 and TL0. Timer 0 have high byte. Timer 0 is low byte. Timer 1 TH1 and TL1, timer 1 high byte and timer 1 low byte. So these were the registers present in uh, the 8051 microcontroller. So here we can see the timer registers. So for the timer 0 and timer 1, these were the registers present. So TMOD resistors. TMOD resist like timer mode resistors are also known as TMOD resistors. So it is an 8-bit resistor. The lower 4 bits are timer 0 mode settings, which are 0000 are not used. So upper 4 bits are timer 1 mode settings, 0000 are not used again. So this was not bit address. So next, the functions of individual bits mode. Here you can see the functions of each mode. So bit 7 was gate 1. So when this bit is set, the timer will run when into 1 is high. When this bit is clear, then the timer will run regardlessly of the state of into 1. Next, C by T1. When this bit is set, the timer will count events on T1. When this bit is clear, the timer will be incremented every machine cycle. So T1 M1, timer mode bit. T1 M0 is timer mode bit. So bit 6 was C by T1, bit 5 was T1 M1, bit 4 was T1 M0. So next was bit 3. So this was the gate 0. So when this bit is set, the timer will only run when in 0. When 0 is high. When this bit is clear, the timer will run regardlessly to the state in 0. Next bit 2, C by T0. When this bit is set, the timer will count events on T0. When this bit is clear, the timer will incrementally every machine cycle. So next was bit 1 was T0 M1 timer mode bit and bit 0 was T0 M0 timer mode. So these are the functions of individual bits of timer mode. So next C by T. C by T has two operations, zero timer operation and one counter operation. So when zero timer operation takes place, clock will be counting the mission cycle. So one will be the counter operation, one will be there. Then the counter operation takes clock TX input. So in the diagram, we can see the timers of 0 and 1 same specs. So next was M0 and M1. So M0 and M1 are the modes. So select the timer mode of the timer 0 and timer 1. So M1 is 0 and M0 is 0, then the mode will be 0. If M1 is 0 and M0 is 1, then mode will be 1. If M1 is 1 and M0 is 0, the mode will be as 2. If M1 is 1 and M0 is 1, then the mode will be 3. So there are the four modes which are present in the like modes of operation. So in the mode 0, 13-bit timer mode will be taking place as 8-bit THXN plus 5-bit TLX, where x equals to 0 or 1. And In the second mode, the 16-bit timer mode will be taking place as 8-bit THX plus 8-bit TLX. In the third mode, which was mode 2, 8-bit auto reload will be taking place. 8-bit auto reload or auto reload timer or counter. The THX holds a value which is to be reloaded into TLX each time it overflows. And the final last mode 3 was split timer mode. So these were the timers as well, like modes M0 and M1, which are present in timers 0 and 1. So once again, we recall these modes. So the microcontroller 8051 has two 16-bit timer or counter registers, namely timer 0 and timer 1, which are also known as T0 and T1. So when we use as a timer, the microcontroller is programmed to count the internal clock pulse. If you use if the microcontroller is using the counters, then it is programmed to count the external pulses. So the maximum count rate is 1 by 24th of the oscillatory frequency. Hence, this oscillatory frequency, like the count rate, is depending on the oscillatory frequency. Okay. So it has two timers or counters, timer 0, counter 0, and timer 1 or counter 1. So these resistors used in the timer as timer 0 resistors are TH0 and TL0 exclusive, and timer 1 resistors are TH1 and TL1. Next, there are two types of timers: timer mode resistor and timer control resistor. So basic resistors are resistor THX and TLX. These are 16-bit wide. These resistors store the timer delay as a timer, the number of events as a counter, the timer 0, TH0 and TL0, timer 0 high byte, timer 0 low byte, TH1 and TL1 are of timer 1 high byte, and timer 1 low byte. So next, this was the register saving format of timer 0 and timer 1 as a TH0, TL0, and TH1 and TL1. Next, T-mod resistors. Register. Timer mode register is also known as T-mod. So it is an 8-bit register. Lower 8 bits and timer 0 mode setting are 0000 not used. Upper 4 bits are timer 1 mode settings. So it is a not bit address. So this is the functions of individual bits of T mode. So the 8 modes are from by bit 0 to bit 8. So C by T. So at 0 timer operation or clock machine cycle, clock was machine cycle at one counter operation will be taking place as clock TX input pin. Next, M0 and M1. So M0 and M1 select the timer mode of timer 0 and 1. This is majorly having four types of modes: mode 0, mode 1, mode 2, and mode 3. When M1 and M0 are 0, the mode will be as 0. M1 is 0 and M0 is 1, the mode will be as 1. M1 is 1 and M0 is 0, the mode will be as 2, and M1 1 and M0 1 is the mode 3. So when the mode is 0, the operating mode will be as 13-bit timer mode. It has 8-bit THX plus 5-bit TLX and 5-bit TLX. Here x equals to 0 or 1. And when the mode is like mode 1, the operation will be as a 16-bit timer mode, 8-bit THX plus 8-bit TLX. When the mode is 2, the operation will be the 8-bit auto reload. Here, 8-bit auto reload timer or counter, THX holds the value of which is to be reloaded into TLX each time it overflows. Next, next was the final mode was the mode 3. Here, the split timer mode is the operation. So in the next session, we'll be learning about the modes of operation. So this is up to the day. So is anybody having any kind of doubts regarding today's session?